Hello friends, welcome to this section of this time series tutorial. So today we will going to discuss like how you can fit your ARIMA model on the transformed and analyzed data. So now your data is stationary. Okay, you have removed the ETS, the error part, the trend part, and the seasonality part from your data. How you have checked? You have done the AD Fuller testing, you have checked the p-value, you rejected the null hypothesis and accepted the data is stationary, and by visually inspecting the rolling mean and average, also you check that data, the mean and the standard deviation is constant. And next thing is the ARIMA model needs the PDQ value, P for the auto-regression, D for the differentiation or the integration, and like Q for the moving average part. So ARIMA model is actually combination of these three things. So these three order values also we have determined. So from the PACF graph, that converges near around 1. So we got the p-value as 1, and like the ACF graph that converges near about 2. So we got 2 as the Q value, and for the period shift or the window of the moving average subtraction, we got the D can be like 2 or 3. Okay, so we got D as 2 because the ARIMA model itself cannot accept D value more than 2. So we got it 2. And let's now get like in this section, we will learn how to train and test split your data. Like you got a very small portion of the sample as the test data to compare the prediction, and the rest of the data will be trained on the statistical model like ARIMA. And then we'll check the prediction accuracy using the residual score as well. Let's start. Please stay tuned till the end. So first thing is you need to import the ARIMA model from stats model dot psa dot ARIMA So there is another version of this package also, ARIMA dot model. So you can import that as well, but you need to pip install it. Let's see how I can do it using the ARIMA underscore model. If I cannot do all these things like the showing all the methodology in one shot, it's possible ARIMA dot model. I will see if it is can be done using ARIMA underscore model, because this is like an old version. Okay, let's see. So now you need also the train test split package. So that is a scikit-learn package. So from scikit-learn dot model selection import train test split. Okay, so now you have the log scale minus MA data or log scale using period shift data, whatever data you can use. But I will use the log scale minus MA data. So here passenger data log scale minus MA, and I have not removed the null record because you have subtracted it. Maybe in some cases it will be null. So I need to remove the null record first, because it will create problem in applying the statistical modeling. So in place is equal to true. And then train test is equal to, then I will use this package train test split, and then I will have here passenger data minus MA, log scale data minus MA, and I will give what is my test size. So test size, according to your confidence, you can choose like 10% or 25% or 30% or even 5%. So my data set is very small. It's just few hundred, not more than 200 as well. So I got the test size should be 10% so that I will get maximum data to train my stat model. So that is test size 10%. Okay. So now let's run it. Is it creating any problem? No. Till now it's good. Now I will have another very important like shuffle. Why shuffle is required? Because it's a time series data. You cannot choose like the 10 records from everywhere. You need to go periodically. So first period will be for the training and the last period will be for the testing, because you are doing the future forecasting. So it will not know where the test data is. That's why the prediction can be comparable to the test data. So to be a future, you need to take the last segment of the data. So shuffle is equal to, so this is very important for a time series data. And then you need to go for the model equal to, and then you will have the data to fit, and then order equal to, what is that? D1, D2, and Q2. Okay. So this is the, I need to fit the model. So fit model dot fit. So it is asking me to choose a different order for Q. Let's have it. Now it is good. Okay. Sometimes it is like Q cannot be greater than P kind of thing. And now I will get my prediction. Like ARIMA fit dot predict, and you can just get the test data info. So test dot, otherwise I need to go for head and tail. No, this is a series, so I need to get. So it is starting from 1959 October. So I'll get my equal to 1959, and then will be, let's get the tail as well. So 1960 December. So it will be 1960. Okay. So now let's predict it. And then I will go for the comparison. Like I will, let's go for another code branch. So now how you know that your prediction is accurate? So there are multiple ways to go for it. Okay, first is the mean squared error. Okay, so you can check for the mean squared error, or you can like visually inspect it by plotting the test data and the prediction data side by side, or you can go for the ACI score, or you can go for the residual score and residual plot and residual histogram like the KDE plot, where you can get the distribution of the residual score. So is it concentrating around 0? If it is concentrating, highly concentrating around 0, so then the residual score is good and your prediction is near about perfect. So let's go for the mean squared error first. So from scikit-learn dot metrics import mean squared and is equal to mean squared error mean squared error, and you need to go for the test data and the prediction data. Yes, let's run it. See any problem is there? No. Now I need to print this mean squared error. So I need to print. You can go for the like and give like a 3 value after decimal, and you can go for the percent. So now your test MSE score is 0.015, like 10%. It's very high. So it should be very near to 0. So let's like plot the predict to now plot plt dot plot the test data test set and then to show it in a different color. And then I'll just show the show. So let's see. So now you see this is not predicting it quite easily. So let me go for the ARIMA dot model. So I told you like this is a like old version. The prediction is not good for it. So it does not know what is this ARIMA model. Let's install it. Let's try for the installation. So now we have installed the stats model again, and we will need to run this prediction, and we will run the mean squared error. The mean squared error is very high, and let's see how this graph is visually comparable. So you see that is not following the test data. Okay, so that means the prediction is not good. Okay, so let's try to increase this value. Let's see, it's 10. So I've just given a abrupt value to the p. Okay, so always I try to increase the p value when the prediction is not good, or like I can give like a number of value and do the permutation and combination. there is another method like auto regression. You can check as well. You see now the prediction is quite good and the test MSE is very near to 0. Okay, so if it is further increasing, let's see how it behave. So it will always be a range. So now the test MSE is further improved. Let's see it give it as 20. Now you see the MSE score has increased. So 20 is not good. Okay. So that's how you need to like go for like a very specific value. Like you can all another like give a range between 15 to 20, like where your MSE score is good, and like you can just check it for like 5 after decimal. So you see the MSE score is 0.0068 and prediction is almost matching the test value. So now I have another way to check for this p-value, because you see that by using this function, I cannot get. So this is converging at around 1 and this is converging at around 2. So I could not see like this is a good value. Let's keep it 2 and see what is my prediction score, like MSE score. Yeah, MSE score has improved a bit, like 0.000682 to 0.00066. But this value is not good. Okay. So let's check it using the auto regression as well. So alternatively, you can go for the like auto regression plot as well. So let's see the what is auto regression plot. So this plot is actually converging towards a whole data set. And when it first reaches 0, so you see the number increases. So that's why you can get an idea that you need to increase the ACF value as well. Okay, PACF value as well, like the P value. Okay, so but P value and Q value is always the range. Now let's see like how can I get the AR model, like ARMA model and the MA model from this same package. Okay, so if you just make, so this is my AR model. So if we just make this Q value as 0, so now this will be your AR model. Okay, and you can get the test score. You see the test score is increasing. That's why ARIMA model is better than the AR model. Okay, the same way you can create the MA model. MA model will be like making this one 0. Okay, let's comment it out and let's run it again. And let's get the score. See, the MA model is also like not better than the ARIMA model. And let's have the ARMA model, the integration part we removed. Like, so this is also created by removing the integration or the difference part. Okay, let's run it. Now, if you just get the score and you see this is also good. Okay, so ARIMA and ARMA model is almost giving you the good result, but if your data is stationary enough, then these two will give you the same kind of result. And now if you just get the prediction, it will give you the correct prediction. That means the red line, the prediction. So now you can see the red line is almost reaching the blue line. That means your prediction and the test is quite accurate, and you can check it using the MSC score as well. Now the next method is you can check it using the uh, residual score as well. So how to get the residual score? So now we will check the residual score as well. So how to check the residual score? So I need to import another library. So from pandas import data frame. Let's run it, whether I have done any spelling mistake or not. No, it's going good. And then let's see dual equal to data frame, and you will get the model ARIMA fit and dot race ID. Okay, so now let's run it, and then we'll plot this residual using a KDE plot. So that will be a distribution plot, and we'll check the distribution, whether the distribution is around the 0 or not. So residual dot plot is equal to KDE. KDE means this is the density plot, the density estimate plot. Okay, and then we just run it and we see whether it is around 0 or not. So how much steeper it is, that will determine how much dense it is around 0. Okay, so you just change this ARIMA model to ARIMA model and check for the residual score. So you see that ARIMA model is more concentrating around 0. So that's why the ARIMA model, or if you don't have the stationarity, if you cannot achieve the data stationarity, then you can go for the SARIMAX model also. That is also an upgraded version of the ARIMA model. So we'll discuss in. So that is how you can check the accuracy of a prediction using the residual score and plot it using a distribution or histogram plot. Thank you so much for watching this video. We will continue our discussion using the COVID-19 dataset, and we will check it how the SARIMAX also works. Thank you so much for watching. Please stay tuned.